Good day. Our laboratory report is all about design of economical air conditioning system of a room at our boarding house in Cogon, Tagbilaran City using air disc cooling technology. Researchers have investigated creative strategies to achieve the highest levels of comfort while having the least negative effects on the environment due to the rise in energy consumption and the need for sustainable alternatives. This laboratory report entitled Design of Economical Air Conditioning Systems at a Room in our boarding house in Cogon, Tagbilaran City emphasizes the effectiveness or cooling system designed in order to achieve desired comfortable room temperature at a lower cost. The primary function of air conditioning is to cool and regulate the temperature, humidity, and airflow within an indoor space. Here are the main functions of air conditioning system. You have here the cooling, temperature control, humidity control, air filtration, ventilation, airflow control, energy efficiency, and noise reduction. So here are also the benefits of air conditioning. You have here the comfortable indoor environment, improved air quality, humidity control, increased productivity. You have here also the health benefits, allergy and asthma relief, preservation of belongings, mold growth prevention, and stop insects and parasites. So in this laboratory report, we have here the objectives. First, to design an inexpensive cooling or air conditioning system suitable for use in a specific room located in Cogon, Tagbilaran City. Second, to determine the condition of the room for different time of the day, room temperature and humidity. Then the last, to provide results and discussion. So we have here the methodology. Upon designing for an inexpensive cooling or air conditioning system in a room at our boarding house in Tagbilaran City, the group conducted first an experimental setup for data gathering. In order to gather room temperature and humidity, the group used Arduino Uno based temperature and humidity sensor. Components required: Arduino Uno, the HT11 temperature and humidity sensor, breadboard, power supply, connecting wires, and I2C LCD. So here's the code we used in programming the Arduino Uno. So for lowering the temperature, the group proposed to use the air disc cooling technology by Maria Isabel Angel Palma. This type of device or technology is suitable for rooms that requires air conditioning units that is very cost efficient. So, what is air disc cooling technology? So air disc cooling technology is a low energy alternative to air conditioners. An alternative air conditioner design that uses only 10% of the electricity required from a conventional installation. The device consists of a rotating set of concentric air tanks through which air is passed and compressed, being cooled in the process. As well as having a low energy requirement, it also bypasses the chemical refrigerants used in conventional air conditioners, avoiding the use of an expensive, toxic, and extremely hazardous material. Air disc cooling cooling system uses free, abundant, earth-friendly air molecules in combination with atmospheric moisture as refrigerant of a revolutionary new innovative cooling system that has minimal use of energy to mitigate global warming. So this is the figure we provide about air disk cooling technology. So we have here the design process. Air disk cooling technology system uses air combined with atmospheric moisture as refrigerant. It is radically more energy efficient than those that use chemical refrigerants in closed system cooling. It deploys open system cooling approach which has low compression pressure and temperature that has minimal low energy. Low pressure does not need strong, thick, costly materials. It employs thin-walled, high-volume condenser cylinders for more effective heat of compression dissipation. Part of our methodology is the room area. So a figure shows here the room area to be designed with inexpensive cooling air conditioning system using air disk cooling technology. So the room area in 3R's boarding house located in Cogon, Tugbilaran City has a room area at 113.02 square feet or 10.5 square meter.
Good day everyone, Davis Francis Neil here. I'd like to discuss in more depth the implications of the parameters to measure. First, we have the dry bulb temperature or the DBT. It is the temperature measured with a standard thermometer that does not have any water in its surface. When people talk about the temperature of the air, they usually mean the dry bulb temperature. Dry bulb temperature is located on x-axis of the psychometric chart, and lines of constant temperature are represented by vertical chart lines. The dry bulb temperature is an indicator of heat content and is shown along the bottom of axis of the psychometric chart or along the left side of the Mollier diagram. Constant dry bulb temperatures appear as vertical lines in the psychometric chart or horizontal lines in the Mollier diagram. In the experiment conducted, the temperature measured by DHT11 with Arduino and the LCD interface with I2C is known as the dry bulb temperature. Next, we have the relative humidity. Relative humidity is the actual amount of water vapor present in relation to the capacity that the air has at a particular temperature. Warmer air can hold more moisture than cold air, so air temperature dry bulb is important. The maximum amount of water that the air can hold doubles for every 20 degrees Fahrenheit increase in temperature. Next, we have the wet bulb temperature. The temperature of adiabatic saturation is the wet bulb temperature. The temperature indicated by a moistened thermometer bulb exposed to airflow is this. Wet bulb temperature can be measured with a thermometer wrapped in a wet muslin. A wet bulb temperature lower than the dry bulb temperature is the air indicates adiabatic evaporation of water from the thermometer and the cooling effect. Next, we have the absolute humidity. Absolute humidity is the total amount of water vapor contained in a given volume of dry air. Water vapor is measured in units of weights and dry air in units of volume, called cubic meters. Absolute humidity then will be expressed in grams of water vapor per cubic meter of air. Next, we have the dew point. The dew point temperature is the temperature at which the water begins to condense from moist air. On the psychometric chart, dew point is represented by 100% relative humidity line, moving from a state point horizontally to the left along lines of constant humidity ratio until the upper curved saturation temperature boundary is reached yields the dew point temperature. At dew point, the dry bulb temperature and wet bulb temperature are identical. Next, we have the specific enthalpy. It is a measure of heat energy in the air due to sensible heat or latent heat. Sensible heat is the heat energy in the air due to the temperature of the air, and latent heat is the heat in the air due to moisture. Next, we have the specific volume. So as we all know, specific volume is the volume that a specific weight of air occupies under certain conditions. Next, we have the psychometric properties of air for good thermal comfort. So, based from Sengel 2004, most people will feel comfortable in a 22 degrees Celsius with ideal relative humidity level is between 30 and 70%, with 50% being the most desirable. While according to WellCare 2021, people generally feel thermally comfortable in environments with temperatures ranging from 22 degree to 27 degree and relative humidity levels ranging from 40 degree to 40% rather to 60%. So table below, for this experiment, the researcher used the thermal comfort from the temperature between 72 degree Fahrenheit or 22.22 degrees Celsius and 78 degrees Fahrenheit or 25.56 degrees Celsius and a relative humidity of 50%. So the obtained parameters based on these values came from this link and it's shown in table 1. We obtained data of psychometric properties of air. So this is the data we obtained. So we have the dry bulb temperature 22.22 as what I have mentioned earlier, the relative humidity and the wet bulb temperature, absolute humidity ratio, dew point, specific enthalpy, and the specific volume. So this table depicts the psychometric properties of air for good thermal comfort. So here we will discuss the results and discussions. So table below shows the psychometric properties of the atmospheric air based from the input values obtained from dry bulb temperature and relative humidity of the test. So these are the time we get this temperature at 6 a.m. to 8 p.m. So in the dry bulb temperature, we got 25 degrees Celsius. At 8 a.m., we got 28 degrees Celsius. And at 10 a.m., we got 29 degrees Celsius. And on the 12 noon, we got 31 degrees Celsius. So as we can see, at 12 noon, it got higher degree of temperature up to 8 a.m. So as we can see, 8 p.m. has a 27 degrees Celsius temperature. So in a relative humidity, we got 84% in a 6 a.m., 80% in 8 a.m. up to 8 p.m. we got 81%. So here are the data we obtained. So this table represents the psychometric properties of the atmospheric air. So when the psychometric properties of atmospheric air were compared to the psychometric properties of air for good thermal comfort in table 1, it was revealed that the air temperature at 6 a.m. is still good for thermal comfort with a temperature of 25 degrees Celsius. However, it was discovered that the temperatures from 8 a.m. to 8 p.m. are higher than the ideal good thermal comfort. As a result, during these hours, a cooling system is needed inside the boarding room. Based on the results, an expensive cooling system will be proposed to address this problem. So, I'd just like to finish this presentation. That's all, and thank you.